Carbon steel slag, an excellent raw material for road construction projects. Limited sources of raw materials on the one hand and the production of large quantities of various types of industrial waste on the other hand mean that we will have to change our patterns of thinking and behavior in the field. Waste of all kinds has become an important source of new raw materials, and its use is particularly promising in the field of civil engineering, where large quantities can be used. New composites made from waste can frequently have better characteristics and can be cheaper to produce than traditional products, and apart from hazardous components in the waste, can be immobilized. Among the most usable types of waste, which are well known in the civil engineering industry and already used routinely, are various types of slag, and in particular slag from electric arc furnaces, which is a byproduct from the carbon steel production process. The raw material for the production of carbon steel is waste iron, to which hydrated lime is added. The slag is created on the surface of the molten steel at a furnace temperature of about 1600 degrees centigrade and is run off into a pit which is located beneath the furnace. About 150 kilograms of slag is produced for every ton of steel that is made. Beneath the furnace, the slag starts to harden. It is then mixed using special excavators, loaded onto lorries and transported to a waste depot which is in the vicinity of the steel works. Here the first stage of the aging of the slag takes place, which consists of 2 weeks of wetting and mixing. In this way the slag cools down slowly and in a controlled fashion, and its suitable microstructure is achieved. A transition of the unstable minerals into stable forms also takes place. The cooled slag is then moved to a more distant waste depot, where it is left to age for a further 30 days. The method by which aggregate is obtained from slag is similar to the method for obtaining aggregate from natural stone materials. 2 stages of crushing are needed, the difference between them being that the slag goes through a separate process of magnetic separation, where iron is removed in 2 stages. The crushed material is then sieved on standard sieves in order to obtain different sizes of granulations. The characteristics of aggregate made of slag are verified in accordance with the requirements of the technical standards for aggregates, which were prepared for professional use at the EU level and which Slovenia has officially adopted into its legislation. Its most important properties are grain size distribution, as well as resistance to crushing, freezing, thawing, wear and polishing. In order to prevent the undesirable swelling of building composites containing slag, the volumetric stability of the slag is also verified by an expansion test. Chemical analysis of the leachates from the slag are also performed in order to check whether there is a danger of the release of heavy metals and thus also a detrimental effects on the environment. Results obtained so far indicate that this type of slag is not hazardous and that its use will not burden the environment. Asphalt is a very important material for the construction of roads. Asphalt mixes consist of approximately 95% of aggregate and 5% of bituminous binder. The input materials have to be suitably stored in the vicinity of the asphalt plant. The aggregate is transported by means of a conveyor belt from the depot to the drying drum, inside which it dries at a temperature of approximately 160 to 180 degrees centigrade. At the same time, it is heated up and dust is removed by means of filters. During the next stage, the aggregate is transported to a system of sieves, sieved into hoppers for hot fractions and weighed before entering the batch mixer. Asphalt mixtures produced in this way are then weighed into suitable lorries and then transported to the building site where they are to be placed. Here they are tipped into the asphalt paving machine and then mechanically spread onto the suitably prepared base. If the placed asphalt layer is to be of good quality, then it must be placed in as short a time as possible after production, and such placing must be uninterrupted and uniform. In comparison with ordinary asphalt mixtures, the advantage of hot asphalt mixtures made from carbon steel slag lies in their better skid resistance. In other words, the road surface is somewhat rougher, which improves the safety of road users.